Welcome back again. We're going to continue our discussion about transforming functions. And in particular in this lesson, we're going to look at how you can reflect the graph of a function in either the x-axis or the y-axis. A little bit of comparison for the moment to what we just did with translating functions in the previous video. In the previous video, we would take a function like y equals f of x, and we would either add a value or subtract to the output of a function if we wanted to translate up or down, or we would add or subtract the value from the input to the input value in order to shift the graph to the left or to the right. Well, so addition shifts up or down or left or right. Whenever it comes to reflections, you're going to see that we're going to be using multiplication, and in fact we're going to be using multiplication by -1 in order to reflect the graph in either the x-axis or the y-axis. And it's really just going to be a matter of, do you multiply the output value by -1 or do you multiply the input value by -1? Each will have a different effect. Let's get right into the rules before I actually do a demonstration this time, because I'm going to need you to see the rule before my demonstration is going to make any sense. We're going to begin with reflecting in the x-axis. And so what I want you to notice in this rule is the negative sign in front of the f of x. If I want to reflect a function in the x-axis, reflect it in a horizontal line, then what we're going to do is we're going to multiply the output value of the function by -1. Suppose the function was y equals x to the 4th power plus 1. In order to reflect that in the x-axis, I would simply multiply that entire output by -1, and it would reflect it. If I had the function y is equal to the tangent of x, and I want to reflect that in the x-axis, I would simply multiply that function, the output of it, by -1. Now see how that looks in action. What I'm going to need you to watch for on this screen is what I'm typing in at the bottom of the equation. There's this input bar, and I'm going to input an equation. And the first equation that I plan on inputting, hey, why not? Let's use the one that I wrote on the previous screen. I'm going to type in the equation y equals x to the 4th power plus 1. And then after that, I'm going to type in y equals the opposite of x to the 4th power plus 1. So I'm going to multiply the output value of the original function by -1, and what's going to happen is that's going to reflect the graph in the x-axis. Watch. Okay, so again, keep your eye on that input value. There you see I got y equals x to the 4th power plus 1, and I hit graph, and you see what it looks like. And now I'm going to type in that input value y equals the opposite of x to the 4th plus 1. And you're going to see that this graph is going to be a reflection of the previous one in the x-axis. And it doesn't matter what equation I type in. Let's go with this one next. Let's say I have y equals 1 over x plus 2. If I want to reflect that in the x-axis, all I have to do is multiply the output of that function by -1. Okay? I'm going to show you that next. Alright, a bit of a weird looking graph, but you can see that what I've input, if you look over to the left, is y equals 1 over x plus 2. Now, I'm going to type in the opposite of that. And I made that one a different color so you can see it a bit better. But you certainly see that just multiplying the entire output of the function by -1 reflects the graph in the x-axis. Any function's graph will be reflected in the x-axis that way. Alright, so now for the rule for reflecting in the y-axis. And compare this one to the rule that we just learned. Whenever you want to reflect a function in the y-axis, we're still using multiplication by -1, but what we're going to do is we're going to multiply the input value of the function by -1 rather than multiplying the output of the function by -1. Okay, so what might that look like? Let's say I had a function like y is equal to, let's say, 1/2 x cubed. Okay, now if I want to reflect that in the x-axis, sorry, the y-axis, what I can do is I can make that y equals 1/2 times the opposite of x cubed. Multiply the input value by -1. Or I could take a function like y equals the square root of x, and I could multiply the input value by -1. I can make this y equals the square root of the opposite of x, and that will make the graph reflect in the y-axis. Let me demonstrate that for you. Okay, you see this is the graph of y equals 1/2 x to the third power, and I'm about to type in y equals 1/2 times the opposite of x to the third power. And there you see that, the y equals 1/2 times the opposite of x to the third power. And you can definitely tell that those two graphs are reflections of one another in the y-axis. And that's going to happen anytime you multiply the input value by -1 for a function. Now you'd be correct to say for this particular function that I actually reflected it in both the x and the y-axis, but the y-axis is what matters here. And I'll show you what that other function we wrote down. We wrote down y equals the square root of x, and then y equals the square root of the opposite of x. You're going to see how that reflects in the y-axis only whenever you do that. Watch this. There's the graph of that square root function right there. Y equals the square root of x. And there's a graph of y equals the square root of the opposite of x. Again, multiplying the input value by -1, reflected in the y-axis. You can see that these are reflections in the y-axis. Excellent. So, pretty straightforward. One more demonstration to do with this, and then we're done with this video. One more video to go from this section. We're going to take a look at the same example 14 that we did a little bit ago, but we're going to do the next two parts right now. I'm going to show you how to take this graph of this function that we don't know the equation of, and how you show the graph of f of the opposite of x. Now, what we know with this is, since we're multiplying the input value by -1, that's going to reflect in the y-axis. Okay, so here's the way you reflect in the y-axis. All you have to do is keep the coordinate just at the same height that it was, but you're going to give it the opposite x-coordinate as it used to have. Alright, this point 0, 0 is going to stay the same. But that point 2, 2 would go to -2, 2. That point 4, 2 would go to -4, 2. That point 6, 4 would go to -6, 4. And then your graph would look something like that. Okay? That's a reflection in the y-axis. Pretty simple to do, right? Then let's look at the reflection when you have the opposite of f of x, which we know is going to be a reflection in the x-axis, because we're multiplying the output value by -1. That always reflects in the x-axis. When you reflect in the x-axis, it's actually the y-coordinate of each point that's going to change. Now, 0, 0 is its own reflection still, but this point 2, 2 would reflect to 2, -2. The point 4, 2 would reflect to 4, -2. And the point 6, 4 would reflect to 6, -4. And then you can just connect those points, and you've got y equals the opposite of f of x. Now you know how to translate functions. You also, this is incorrectly labeled, know how to reflect functions. Great job. See you next time.